Hello students, welcome into the another session of CS22 operating system concepts using Linux and Unix. As all of you knows that we have started with unit number 2, which is called as process management. In our previous session we have defined the definition of process, and then we try to convey process is internally divided into the 4 sections called text section, data section, a sorting section called heap sorting section, and the stack. This entire architecture resides into the main memory of the computer, that is called as random access memory. That random access memory is a primary storage device which holds all that processes before it get executed. Now this was all about the previous lecture that we have already discussed. Then we have stopped our discussion in previous lecture at a very important topic as per the university examination is concerned, that is called as process state diagram. So question may be asked like this: what is process? Draw and explain process state diagram in examination. So today's discussion will going to start from process state diagram. Now this is the diagram called process state diagram. As you can see on the diagram, it contains different components like different state like new, ready, waiting, running, and terminated. This is we can say that it concerns with the process life cycle from the birth of process till the termination of process. All this activity has been handled during the process execution. Say for example, suppose any of the process get evaluated by central processing unit or generated by the central processing unit, then that process is called as new process. It got admitted into the stack of storing all the process. As we know that process can be of any type called mini process, micro process, or major process. Once they get admitted, they are considered as a ready process. If input and output devices who is going to handle that particular process is not free, that means the resources are not free, then that process have to wait for a fraction of time. So for the waiting period, it goes inside the third component called waiting state, in which if the response is not returned by the input output devices, automatically it stores inside the waiting state. But if the input output devices are free, then scheduler dispatch that particular ready process into the running state. That means from ready to running process can be switched. It's a toggle state where it indicates that if toggle state returns 1, then the process transfers from the ready state to the running state, and if toggle state is 0, then it should be into the waiting state till its toggle state returns is equals to 1. Now during this, that means from switching from ready to running, during this even the process get interrupted if uncertainty generated into the system and system or user has interrupted that particular process, even it can be possible during the switching between ready state to the running state. Now a new word is introduced over here called interrupt. It's a system interrupt, but I would like to convey it with a human interrupt first. Say for example, two persons are talking together and some third person comes in between and interrupt both the parties. For a fraction of time, they stops discussing with each other. That is called as human interrupt. So same like that, system interrupt can be done by the other resources. What actually does inside the interrupt? Into the interrupt, whatever the processes are switching from running state to the ready state to the running state, they get disturbed by the other resources, that is called as interrupt. In interrupt, it might possible that interrupt is of short time or it might be of a longer time. If it is a short time interrupt, then within a fraction of time again the process starts working on a specific task for which it is evaluated. If it is a longer interrupt, then dynamic memory allocation might free up the resources by generating the exception that this process have some problems. So interrupt is one of the major part of entire operating system. But in short, we can say that interrupt is a one type of disturbance during the regular processes, during the regular execution of the processes. Anyways, whatever the ready process switched into the running state, once the task get completed, it should be terminated automatically by the central processing itself. Why it requires to do so? Because once the termination of the executed process done, whatever the resources allocated for that particular process gets free, that means CPU can reuse all that resources for the other process, other executions also. Again I am repeating my words. Once the process is evaluated by the central processing unit, it will not evaluated automatically. Many resources are occupied for that particular process. Once they run and finish their task, then it should be automatically terminated, because resources which is previously allocated by the central processing unit should be released for reusing into the other processes. So the last state of the process is terminated. So this is the entire diagram in which it try to says that starting from the new to the terminated state, process comes from the central processing unit and executes by the various input output devices. Now all these components are explained in detail over here. In the process state diagram, one component called new, it indicates that the process is being created. Second component is ready. That means actually it is a waiting stage where this entire bunch of process or processes is in a waiting queue to be assigned at central processing unit. Third one is running. Running indicates that whatever the instruction stores inside the process are getting executed one by one. Fourth one is waiting. This particular component says that the process is waiting for some event to occur, such as input output completion or the confirmation given by the external resources. And the last one is terminated. It indicates that the entire life cycle of the process is about to finish or already finished. Release all the resources which has been occupied by that particular process or the bunch of process. So this was all about the component, or we can say the events, which is handled by process in a process state diagram. Now this entire management is done by one of the component of central processing unit, which is called as program control block, which is in short called as PCB, or even it is also called as someone also pronounce this like process control block also. Both are correct. Now, what is the functionality of this process control block? In process control block, one another component is there called program counter. We'll discuss program counter after some time, but let's first justify about the process control block. This all component, that means new, ready, run, waiting and terminated, is maintained by process control block. So that process control block is a one hardware which resides inside the central processing unit for giving the proper instruction set to each and every component without wasting a single moment. Now, during the execution of process control block, the sub component of process control block, which is called as program counter, counts the number of processes which has been executed by the central processing unit. Why the operating system need to go for counting the number of processes which has been executed by the CPU? Just to check from the list of processes how many processes are get completed successfully, and how many processes are in waiting state, and how many processes are in a ready state. So to check the queue of every components, that is ready, running, waiting, terminated, program counter works. Now, even that program counter instructs the CPU that from the bunch of processes, say for example 100 processes is evaluated by central processing unit, and from that 40 processes gets completed properly, then the terminated state is 40. During this 20 new processes get added into the process state diagram, then the state of new is 20. Parallelly with this, 30 informations are running from the bunch of 80 processes, then the program counter of ready is 80, and so on. So this is the main task of process control block, which contains program counter. That program counter actually holds the address of next instruction to be get executed into the process state diagram. Now that process state diagram can also be represented in this format. This format is a stack format where you can see that first one is process ID, then process state, process pointer, process priority. Process is a common word, so I will not speak. Program counter, CPU register, input output information, accounting information, etc. Now during this process control block, process scheduling should be maintained by central processing unit also. That means once the first process get executed successfully, the second process, without wasting more time or taking any confirmation from the central processing unit, it should be executed into the process state diagram. So that could be done using process scheduling. What does it means? The process scheduling is actually the act of determining which process is in a ready state should be moved into the running state, known as a process scheduling. That means we says that whatever the processes are in running ready state should be switched into the running state. But whenever the processes are shifting from ready state to the running state, that activity is called as process scheduling. The technical word is attached with that particular switching. That is called as process scheduling in short. Now the primary aim of the process scheduling system is to keep CPU busy all the times and deliver the minimum response time for all the programs to achieve a faster output. For that, scheduler must apply appropriate rules for swapping input and output processes for the central processing unit. Now these schedulers are internally divided into the two subtypes, that is called as primitive scheduling and non-primitive scheduling. It is just something like rule or unruled scheduling. So let's see first non-primitive scheduling. Whenever the process is given voluntarily to the central processing unit, it is called as non-primitive scheduling. Reverse of that is when operating system decides the favor of another process and priority is given to that particular process for assigning the resources of central processing unit, that is called as primitive scheduling. Let me repeat it again because it's very important. Process scheduling works in between running and ready state of process state diagram, in which it look after between the swapping of input and output processes. The main task of process scheduling is to keep busy the central processing unit for the execution of number of process. During this, it acts in two different ways, like primitive and non-primitive. Into the primitive, operating system decides the priority of process and it assigns that particular process to the central processing unit. And reverse of that, without any priority, central processing unit accepts a particular process from the bunch of process, that is called as non-primitive scheduling. Why we are discussing about these two types of scheduling? Because generally what happen into the operating system, let's first clear that thing. Into the operating system, everything is scheduled. That means operating system itself decides which process is going to be executed by the central processing unit. But if we considers that for some moment there is no role of scheduling, then what happens? Important process get resides into the waiting state and miscellaneous processes get executed by the central processing unit. Ultimately, user will not get their proper answer at a desired time. So that's why there is a very important role of process scheduling is there. Clear? Let's move on. Now this all these process schedulers use a one strategy called scheduling queues. What is scheduling queues? In scheduling queues, all the processes when enters into the system, they are stored inside the job queue. That means all the processes are in ready state is placed inside the ready queue. Then reverse of that, all the processes which are in waiting period put inside the process waiting for a device to become available based on device queue, which inquires frequently the input output resources. A new process is initially put into the ready queue and it waits in the ready queue until it gets selected for the execution, or we can say it gets selected for the dispatch. Once the process is assigned to the central processing unit and it is getting executed, several other events might handle by the central processing unit. That events are: the process could issue an input output request and then it should be placed inside the input output queue. The process could create a new sub-process and wait till the termination of a previous process, as that particular process is similar like a previous one. The process could be removed forcefully by the central processing unit as they are unnecessary, occupying the internal resources of the system and they are interrupting the ready queue. This was all done by process control block and their internal component called process scheduling, program counter and scheduling queues. I hope this is bit little higher to get understand, but if you take it very seriously and listen every word carefully, then it becomes very easy. Before going ahead, that means into the next slide, let's discuss this process scheduling once again. That means third time I am trying to convey the words which is written over here. Process scheduling is actually the component of process control block. That process scheduling schedules the number of processes for central processing unit to keep it busy. That means it works just like a personal assistant of a owner of a company. One by one, owner of the company look after the different executions that they have to take for the company. Similar like this. Let's come back to the topic. Sorry for the other example. So this process scheduling keeps busy the central processing unit every times by passing one by one processes from the scheduling queues. Now during this execution, it counts the number of processes which has been passed from ready state to the running state. Just to indicate that central processing unit, these are the number of processes are still in a queue to get executed in future. Now that process scheduling is of two types called primitive and non-primitive, that is planned and unplanned. Generally operating system go for the planned scheduling, but unplanned scheduling can also be done by the CPU if number of processes are very less, priority of the processes are very less. During this, that process scheduling use the processing queue, that means it relies onto the second component which we have discussed into the running state called ready queue and the device queue. Ready queue is a queue which is ready to get shifted from running state to the ready state, and the device queue are the queues which waits for the input output devices resources to get free. Now during this scheduling queue also watch the execution of process. If that execution is taking longer than the required time, then that queue forcefully stop that particular process from the central processing unit, or even it might generate the interrupts. Now all these things what I have speaked is mentioned in this particular diagram. This is the second part of process state diagram, where you can see the several components like ready queue assigned to the central processing unit. Central processing units forward it if everything is perfect, otherwise they are going to check about the input output request, time slice. It consider as a fork child, waits for the interrupt. If interrupt executes, it returns it as an interrupt into the central processing unit, and it forcefully transfers the process from running queue to again a ready queue, or it might delete that particular process and allocated resources from the system also. Now this was all about, we can say that process control block contains program counter and process scheduling. That process scheduling is actually of three types. So the question might be asked into the examination like this: what is process scheduling? Explain the different types of schedulers. So right now we try to discuss about the types of schedulers. In operating system there are three types of schedulers are there. These are long term scheduler, short term scheduler and medium term schedulers. One common thing, obviously we are going to discuss all these three schedulers one by one, but one common thing in all these three schedulers are swapping of the processes from ready to running. All these three schedulers works for that purpose only. So let's see that what is long term scheduler. First of all, long term schedulers executes very less into the system. That means long term scheduler learns less frequently. Frequency of executing the long term scheduler is very less, by the central processing unit. Keep this thing in your mind. Long-term schedulers are not frequently handled by CPU. Long-term scheduler decides which program must get into the job queue from job processor. It selects the process and load into the memory for execution. Primary aim of job scheduler, long-term job scheduler, is to maintain the good degree of multi-programming. So, one thing is clear, long-term scheduler specially used to design and handle multi-programming operating system. Keep this particular discussion over here for long-term schedulers. Short-term scheduler means this is also known as CPU schedulers, and it executes very frequently by the central processing unit. That means the one of the most important scheduler from these three is short-term scheduler because it is frequently handled by the central processing unit. The primary aim of this scheduler is to enhance CPU performance and increase the process execution rate of switching the process from ready to running state. So, short-term scheduler is very much attached with the central processing unit. Again, I am repeating few words about long-term and short-term. Long-term scheduler executes by the central processing unit very less. The primary aim of long-term scheduler is to handle the multi-programming requests for the central processing unit, while short-term scheduler is frequently executed by the central processing unit. The primary aim of this scheduler is to enhance the CPU performance and executing the process execution rate. Intermediate scheduler, which works in between long term and short term, is medium term. This particular scheduler removes the process from memory and reduce the degree of multiprogramming. At some time, the process can be reintroduced into the memory and its execution can be continued where it is left off. This scheme is called as swapping. Now, when the medium term scheduler get introduced by the operating system, for these types of processes who is just switching it between ready and running, they are not getting terminated by the central processing unit automatically. At that particular moment, medium term scheduler executes and look after to the processes which are just coming and going back into the ready and running state, that is called as swapping. This is the diagram which is related with the same execution. We will not discuss this thing in detail. I know whatever you have listened is very difficult to digest. What we have to do is listen all these words again and try to digest each and every word one by one. Now, in our next lecture, we are going to start a very important concept that is called as process scheduling algorithms. You can see the list of algorithms onto the screen. All that algorithm will discuss one by one. Theoretically, we have to not implement all these algorithms. So, sit back and relax, you have to listen only. Obviously, we will start with first come first serve first as a first algorithm. So, wait for that particular discussion. Before concluding my lecture, in this particular discussion, we have go in depth the discussion about process state diagram, the component which resides inside the central processing unit for handling the process state diagram called process control block. Process control block contains two sub component called process scheduling, which might be primitive or non-primitive, and then we have discussed about scheduling the queues. All this discussion we have done with the types of scheduler discussion, that is long term scheduler, frequently used short term scheduler, and intermediate scheduler called medium term scheduler, which look after the switching between ready and running process states. And then in next lecture we'll start with different types of process scheduling algorithm. Thank you very much students for listening me, and have a nice day.